Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Set 103, Palindromes and Arrows by Nicholas Duhale. And here are the rules. Normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box. The sum of the digits along an arrow is equal to the digit in the connected circle. So, for example, if this were, say, 3 and 4, this would have to be 7, because these two digits along the arrow must sum up to the digit in the circle. And that's an example of how arrows work. And then gray lines are palindromes, which contain the same sequence of digits in either direction. So, for example, you could have something like 35753, and it reads the same this way as it does this way. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, for palindromes, where should we start? Well, this has to be, okay, so this is 3 unique digits adding up to another digit, so this must be 6 through 9. This is 3 unique digits here adding up to another digit, so this is also 6 through 9. These digits are 1 through 6 here. These digits are 1 through 6. These digits are the same. Okay, these digits are the same. These digits are the same. And these digits are the same. This digit and this digit is the same. This digit and this digit are the same. These two are the same. These two are the same. Okay. So, where... Orange and blue both have to be these. We don't know which. Red cannot be here or here, so red has to be one of these 4. Pink cannot be here and here, so pink can be one of these 4. Medium gray cannot be here and here, so medium gray has to be one of these 4. And light cannot be here and here, so light is one of these 4. Okay. So that's the limitations in box 9 so far. This digit is not the same as any of these, is not the same as any of these. Interesting. Cannot be on the diagonal here. So it's not the same as, so this is 4, right? So it's not, this digit is not the same as these. It's not the same as these. And that's the same as these cells and these cells. So this digit must be one of these 2 here, because it can't be the same as any digit on the line. And it's not the same as any of these, period. The light and the, So light and medium cannot be any of these 4, so it doesn't match any of these. Okay. What else do we know? Um, they could be along the diagonal. Hmm. They could even be along the same line, right? Because there's nothing to disqualify these two from being the same as these two. Because they're not in the same row or column. Mm-hmm. Okay, red and light cannot be here. So red and light, one of them could be here or in column 8 or one of these two. Or they both could be here, right? So this is yellow, green. These are different colors. So this dark is not the same as this dark here. Is this helpful? I'm not sure. We have green, light, and red. We have also medium or dark too. So this is green or dark, and these could be green or dark and green or dark. This could be red, light, green, or dark here. Green could be any of these. It's not helpful. Hmm. What about this? Does this palindrome help us any? Nothing that I can see. Okay, so this matches this. This matches this. This matches this. And this matches that. So orange has to be one of those three. Blue has to be one of those three. This cannot be dark orange or blue. But it could... Okay, so what can these be? This is yellow or green. We don't know which, right? Because it can't be any digit along the arrow. It cannot be light or medium or orange or blue here. What else do we have? These digits are light, medium, green, pink, red, or yellow. But that could be a lot of things. Right? So dark has to be this dark cell cannot be any of these cells because it sees these two and it sees these two and it sees that one from this cell. So it must be one of these three. Okay. Does that tell us anything? I'm not sure. Um, Hmm. Where is light is here and here, so that means light must be one of these three. Medium's here and here, so medium has to be one of those three. Light could be here, medium could be here. So that doesn't eliminate any of those. We do have certain things, which is not related to colors or palindromes. These 3 digits plus these 2 digits must equal what these 2 digits are. So it has to be some combination adding up to 15, 16, or 17, because that's the max that 2 unique digits can add up to. This then has to be adding up to 17 at most. And that would therefore be 1 through 7 in these cells. You could have 1, 2, 3, 4, 7. Obviously, 1, 2, 3, 4, 5. 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 6. 1, 2, 3, 4, 7. 1, 2, 3, 5, 6. So that means the rest of this box cannot contain 1, 2, or 3. So it must be 4 through 9 here. So this digit has to be the same as one of these 3. That means it's also one of those 3. Ah! And it cannot, so yeah, this digit cannot be any of these digits along this arrow because they all sum up to that digit. Can't be any of these in this row, so it must be one of those 3. Since it's one of those 3, where is it in row 7? It cannot be here because of that digit in the box. Cannot be here because it adds up to that digit. So it can't be the same as that digit. So it must be one of these 3. And because of this palindrome, it cannot be this one. So this is the same digit as this. We know this digit has to be one of these 3 digits because it cannot match any of these 2 digits. It cannot match any of these 2 digits. And it can't be, it's the same as a digit, the digit it's adding up to. So it must already be here. The question is, do the other 2 have to be on here? And the answer to that might be maybe. I don't know. That's interesting. It doesn't give us too much information, though. So this must be the orange one of those 2. Cannot be here. It could be any of these. Where is it in row 4? It cannot be here because that matches this cell, and this cell sees it. Cannot be here because it matches that cell. Cannot be here. Can't be here. So the orange in row 4 must be one of these 3. Obviously, if it's 9 here, oh, that's interesting. If this is 6 or 7, these digits are exactly the same. So it must be exactly the same as these. So let's make that red, pink, and dark. So then this would have to be red, pink, and dark. right? Because they add up to the same digit as long as this is 6 or 7. uh, uh, um, so this could be the orange one. Actually, so, okay. Say, that's interesting. So say this is 6, right? 6, this becomes 1, 2, 3. This has to be 9, and this is 4, 5. So this could not be 6 here. This would have to be 6 here. So in that case, this is the orange. And one of these is the orange. That's interesting. What happens if it's 7 and 7? Then this is 8 or 9. This has to be 1, 2, and 4. And this cannot be 7 here, because it would be 3 and 5. Or 3 and 6. I think this always has to be orange then. So we've tried 6 and 7. What happens if we have 8 here? If this is 8, this can never be 8. So we know for certain this orange cannot be either of these cells. If we had 6 here, that's 1, 2, 3. This is 4, 5, and that would have to be 6. If this is 7, this is 1, 2, 4. This is 3, 5, or 3, 6, and that would have to be 7. If this is 8, it obviously cannot be here, because to add up to 2 unique digits, that's at maximum 17, and 8 cannot be here. And so 9 is here. So this is always the orange then, which means this cannot be orange. So this is always orange, which means that cannot be orange there. So in row 4, the orange has to be one of these two cells. This cell sees that cell. This cell sees these two and these two. So it cannot be the same as these two, because these are the same as those. Cannot be the same digit adding up to itself. So there can't be the, also this orange sees that one. And these two digits see these two digits here are the same as these two digits, which both see orange. So, and this is orange, we've proven. So this cannot be orange here, which means this is orange. So this cannot be 9. It's guaranteed to be 6, 7, or 8. Which means this can't be 6, because that would be at maximum adding up to 14, which is 6 and 8. And we know 5 digits add up to a minimum of 15. So this cannot be 6. This is 6, 7, or 8. We know a 1 is guaranteed there. So this cannot be 1. Because if it's 6, it's 1, 2, 3. If it's 7, it's 1, 2, 4. If it's 8, it's 1, 2, 5, or 1, 3, 4. So this is 6, 7, or 8, which forces this to be 7, 8, or 9. So we have a guaranteed 6, 7, 8 here. The other one is 1, 2, or 3 here. To add up to that digit. Orange is here. So orange cannot be either of these cells. So orange in box 6 must be one of these two cells. Interesting. Okay. That's interesting. Because these are the same then. So we had some mapping here, which was interesting. And that was... Okay. So we're going to make this dark. I don't know what we make this. No. I guess we'll make it green, blue. This will be pink, medium, light. This will be yellow with the orange, and this will be red. Red has to be the same as that. This is pink again. So this is green and this is blue. So these digits cannot be blue or green. So one of these must be blue or green here. Orange is here and here. Guaranteed. Where is dark? Dark is not any of these. Dark could be any of these. So that's fine. Medium. Medium is here. Light is here. So medium cannot be any of these or these. So these could be medium. Light cannot be here or here. So light could be either here or here. So we've got all of these covered. Yellow could be any of these. So not very helpful there. Pink cannot be here and here, so pink has to be one of these three. Red cannot be here and here, so red is one of these three. Okay. Remaining digits in row 4. We have yellow, red, pink, green, and blue. Okay. So this is yellow, red, pink, green, or blue. This can't be pink or green because of the pink and green in a row. So this can't be pink or green. This can't be blue or red because of the blue or red in the row. So this can't be blue or red. We know whatever's this digit must match one of these. So we know light has to be one of these three. Red has to be one of these three. And pink has to be one of these three. Okay. That's interesting. Where is the 9 in row 8? Or actually in box 9. Cannot be here because this matches this one and that can't be 9. So it must be one of these three. That's interesting. So the only way these three are different than these three is if this is 8. Okay. Huh. Hmm. Ah, where is the medium in row 8? Medium gray. It cannot be these cells. It cannot be these cells because of the palindrome and the orange. So it has to be one of these two cells, which means this cannot be medium. This cannot be medium. That's interesting. That means the rest of row 8 has to be what? It's not any of the grays. Well, it could be dark. Can't be light or medium. It could be dark green, no pink, no orange, no red, yellow, or blue. Interesting. And one of these has to be the medium gray. Interesting. Only one of blue or green is here. If this is a blue-green pair, that means both of these have to be blue and green. Okay. Does that tell us anything? Not particularly. What's interesting, though, is if this is... So if this is a 6 or 7, these three are the same as these three. Though it's interesting if it's 8, right? That forces this to be 9. So if this is 8... Ah! Okay. Interesting. Yes, we have another interesting information. And it's not about box 6. What's interesting is if this is an 8, that guarantees this has to be an 8 here, which forces it to be 1 and 8, which makes this 9. But then this digit, we know, cannot appear in any of these cells and can't be here, so it must be along this line, which means 1 is guaranteed to be here, and 1 has to be here, and this cell must also be on that line, and it cannot be a 1. Also, yeah, we know these can never add up. These can never have a 6 in it, because if they had a 6 in it, that would be 1, 2, and 6 at minimum, which adds up to 9. And we know these 3 cells must be exactly the same as these 3. Because this cell has to be in this set for in row 7, because it sees these 2 cells, so it can't be here. It sees these 2 cells, so it can't be here in row 7. It adds up to that cell, so it can't be that cell, and it sees that cell in column 6. So it must be here. And if this is 8, which is the only case that these 3 are not the same as these 3, this must be 1 and 8 adding up to 9. Because we know the orange has to be here. So because of that, this can't be 1 anymore, so it's another unique digit plus 1, which have to be here, which means that these 2 are the same. So we are guaranteed these 3 digits have to be the same as these 3 digits. That's interesting. What does that mean? I'm not sure, but these 2 are the same as these 2, so we'll make them blue and green. That makes this blue and green. These two match these two. So we'll make that light and a medium. And that's light and medium. Oh, interesting. So this is the same cell. I guess it's the last cell, so it's yellow. In row 7, column 6, we have exactly the cells that we need. So this must be pink or red, and this is pink or red. Red cannot... Okay, so red... So the rest of these digits are, again, some combination of yellow, light, and medium. So this is light yellow or medium gray. Okay. Um... let's use these as the... So these are guaranteed to be exactly the same as these. We have 6, 7, or 8 here. These two could be either these two or these. It's basically one of these 5. Okay, what happens if we make these essentially light and medium? Does that change anything? And the yellow is one of these two. Well, that makes this light and this medium. Again, these could be light, medium, or yellow. This is light, medium, or yellow. This would also be light, medium, or yellow. And this would be red or pink still, and red or pink. That's fine. Medium has to be one of these. Light has to be one of these 3. Interesting. Okay. This is 1, 2, or 3 here. If this were 6 and 7. So if this is 8, this is guaranteed to be 1. So this would have to be one of these 2 cells here. If this were 6 or 7, if it's 6 and 3, then the 3 would guarantee to be here because this is 1, 2, and 3. If this is 7, this would have to be 1, 7, or 2, 7, adding up to 8 or 9. But if it's 7, this is 1, 2, and 4. So the 1 or 2 would have to be one of these 2. Therefore, this is guaranteed to be a red or a pink here. Remaining digits in row 4 are... This is orange. We need yellow. We need pink, red, yellow, green, or blue. So pink, red, yellow, green, or blue. So these match that. That's red, yellow, blue, green, pink. The digits in the circles here can be 3 through 9, so that's not very helpful there. Um, hmm. Mm-hmm. Um, hmm. So say these are all 8. Actually, no. What we wanted to try was 2, 7 here. Which does force this to be 9 and 8. So this is 8, 8, 8. So this becomes 1 and 8 here, adding up to 9. So this cannot be 1. This can't be 2. So this must be 1, 3, 4. Cannot be 4, 9, 7, or 8. It's a 5, 6 pair. That forces this to be 1, 3, and 4. But this can't be 1. We have 5, 6, and we have 2, 7, and we have 9. Okay, so 9 cannot be either of these. 9 has to be one of these. 8 is one of these. So 8 is also one of these two. 8 could be here if this is 9. Ah, if this is the case, these two cells must be the same as these two. So where are the 8 and 9 in column 8? They cannot be here because of the 8 and 9 in the box. They can't be here because they both see that cell, and this is the same as that. They both see these cells, so this cannot, and this is the same as that. And they both see this one. So one of them's here, the other one is here. So if this is 8 or 9, and this is 8 or 9. Interesting. So that's possible. So if this is 8, this would have to be 9. This would be 8, and that would be 9. Okay, that seems feasible. 9 means, okay, so this is not 9 here. Oh, where is the 9 then? This 9 does not see this cell. So that could be 9. So the 9 could not be here because that's pink or red. Actually, we have that information, so that's useful. So we don't need any extra additional information there. Let's continue. So this has to be 1 through 5 here. So this is 1 through 5, this is 1 through 5. So these are light, medium, cannot be dark, it's green, no pink, no orange, no red, yellow, or blue. So those are the possibilities. Um, okay, so we have all that information then. So these match exactly these. This has to be 1 through 5, and this is 1 through 5 because it matches these two. One of these matches one of these two. Huh. Yeah. So if this were 7, and this would be 1, 6, obviously. This couldn't be 1. This would have to be 6. This would be 6, 6. This would be guaranteed 9. So this is 1, 2, 3. And this is not 2 or 3. It's 4 and 5. This can't be 4, 5, 6, or 9. So again, this is 1, 2, 3 here. This can't be 1. This can't be 1. This can't be 1. Sorry, this can't be 4, 5. That can't be 4, 5. That can't be 4, 5. Not sure what I was saying. 7 cannot be either of these or either of these. Oh. Okay, we have another interesting little tidbit. Where is this digit in row 4? This cell, C, cannot be any of these because it adds up to it. Cannot be here because it sees it by its normal Sudoku. It sees all of these digits by normal Sudoku, which matches this as a palindrome and this as a palindrome. And again, this cell is less than this orange, which this orange is guaranteed to be less than the blue. So the blue cannot be here. The blue has to match this one. Interesting. Oh. Okay. So this blue cannot be here, cannot be here, cannot be here because it matches that as a palindrome. Can't be here because it's greater than orange, and this orange is greater than that cell because this cell adds up with 2 other digits to add up to that cell. It sees these 2 cells from Sudoku, and these 2 match these 2 in palindrome, so it must be this one. Since it's this one, if this were 8, I guess this could be 7. But, okay, so if this is 7, this is guaranteed to be 8. I guess the question is, can this ever be 7 here? And I think the answer is no. If this is 7, this is 2, 7, which forces this to be 9. That makes this 1, 3, 4, so that's 8, 8, which forces this to be 9. And then we'd have a contradiction where that's a 9 and this is a 9. So this can never be 7. Can you have 6 here? It could technically be 2, 6. This is 8, 7, 7, 9. So this is 7, 8, or 9 here. Okay. Where is the orange in column 8? The orange in column 8. So where's the blue in box 9? Blue cannot be here. Blue cannot be here because it's 7, 8, or 9. Blue can't be here, so blue must be one of these 2 cells. Interesting. So blue cannot be here in column 8. It cannot either be any of these cells. It can't be any of these cells because it's already sees itself. So blue in column 8 must be here or here. So blue cannot be here. Blue cannot be here in box 3. Where can blue be? Blue cannot be here. Technically, it could be any of these 3. But if it were here, that means it's not a 9. And it's also, that would make this not orange. So where would orange be in column 8? It would have to be here. Because it sees these cells as a palindrome from normal Sudoku. It sees this cell from palindrome. It sees that cell from palindrome. It would have to be here. And these are the same. These are in the same box as the orange here. That's interesting. So this cannot be 8 anymore, right? If this is, I guess it could be 7. It just can't be 8 and 9. So this is 1, 2, 3, 4, 5, or 1, 2, 3, 4, 6, adding up to 15 or 16, because it can no longer be 8 and 9 here. It could be 7 and 9 as long as that's 8, right? This blue is always greater than orange. But this is not guaranteed to be greater than that cell. So this can never be 4 here. Can this ever be 3? Is kind of what I'm thinking, right? And I think the answer to that is no, right? Uh oh. Got something in my eye right now. Oh, that's bothering me. Oh man, there's something in my eye. Uh, okay. Oh no. This is really bothering me. Mm, it's just itchy. It's just like, yeah. Oh, I gotta tear it out somehow. Okay, I think I got it out. Oh, that was irritating. Anyways, if the blue is here, so obviously if orange is here, this can't be blue. So this would have to be blue. Um, If this is... Okay, where is blue in box 2? It's one of... It cannot be here. It's one of these 5. So obviously if blue's there, that's fine. Blue can be here. If blue is here, that means blue cannot be here, so blue would have to be one of those 2. Okay, yeah, where is blue in column 6? Blue cannot be here because it sees it by normal Sudoku. This blue sees these... actually, I guess it could be these 2. Blue has to be in row 7, one of these 3, or one of these 2. It can't be this one, though, so it's one of these 4. So blue in row 7 or column 6 has to be one of these 4 cells, and it must be one of these 4 cells. Right? So these 2 match these 2. So these would be the same. It could be just that one. It could be this one, which matches that one. Ah! Okay, yeah. No, that doesn't help too much. But where's blue in row 2? Can't be here. Can't be either of these 2 because that sees the blue cell here. This cell sees that cell, which matches that. And this one sees that one by normal Sudoku. So blue has to be one of these 4 in row 2. Obviously, if it's on the arrow, it can never be 9 because there would be another digit plus it adds up to another digit. So obviously would not be the largest digit, which would be 9. Okay. So if this is 9, then it has to be here. It does not match these. It would have to be 9 here and here, which eliminates 9 from there and there. So 9 would have to be one of these 2. Obviously, this would be 9. Okay. If this were 6 here, it would have to be 3 and 6 because it cannot be 2 and 6. If this is 2 and 6, this is 8, which forces this to be 1, 3, 4 at minimum. And that would be 8 also. And it could not be 9 because these orange must add up with another digit to add up to blue. So if this is 6, it's 3 and 6. So this is 3, 6. This would be 9. This would have to be 1, 2, 4, and adding up to 7. So this would be 7, 7, 7. This would have to be 1 and 7 adding up to 8 because this could no longer be 9 and obviously can't be 7. So that would be 8. Oh, wait, hold up. This digit, I guess we'll mark it as yellow. Where are yellow and orange in column 8? Can't be here because they're in the same box. Can't be here because they both see the yellow and they so therefore it cannot be these two cells because they both see these cells and they're the same as those. Orange and yellow both see this one, so it cannot match these. So orange has to, again, orange can't be these because it sees those. So orange must be one of these two. Where is yellow? Yellow cannot match these two, cannot match these three, can't match that one. But yellow could be here, here, or here. Blue is one of these two. Interesting. Okay, so let's go back to this 3, 6. So if this is 3, 6, that would mean this would have to be 1, 2, 4. So this is 7, this is 7. This is 7. This has to be 9, so that forces this to be 8. So this is 8. This is a 1, 7 pair here. This has to be 1, 2, and 4. It cannot be 1 here because of the 1, 7 pair in the row. This cannot be 6. Cannot be 9 or 7. So both of these cells see both of these cells. So neither of these cells could be here. Obviously 8 is one of them, so it's matching that. Ah, okay. I see it. I think. These two cells match these two cells in box 6. This cell matches this cell in box 6. Where is this cell in row 8? Cannot be these 3 cells. I guess it could be this one technically. No, it cannot be. Because if this cell is the same as this, and they both see these 2 cells in box 6. So this cell cannot be any of these cells because it's in the same box. Cannot be any of these cells because it's the same cell as that one, and these are in the same box. Cannot be the orange because it's one of those. So this cell must be one of these 3. It cannot be the blue one. So it's either the other digit here, or it's yellow. And it could very well be yellow. We don't know. Whatever cell it is here matches this. We know that for certain. So whatever cell this is must be the same as that. They cannot match here. It cannot match here in row 8. So it must match either here or here. Okay. Does that help us any? I'm not sure. Let's say it matches this one and does not match this. So then we know this is blue. So this cannot be blue here. This is dark, this is dark. This cell, orange, where are orange? And this, I guess we're marking that as yellow. Well, they can't be here because they're in the same box as it. Can't be this one because they both see it, this cell here, and it's the same digit as that one. They both see this one, and we've already marked that this dark gray is the different one. So this would have to be orange or yellow, and this would have to be orange or yellow here. So blue would be here, blue would have to be there. And blue would have to be one of these two. Well, if this is yellow, blue could be there. If this is orange, it cannot. So this would be blue then. I'm thinking blue is likely this one, but I'm not sure. Hmm. Um. So that doesn't necessarily narrow things down. Not as much as I had hoped, at least. Hmm. So we have essentially similarities in row 4 and column 3. We have similarities in row 7 and column 6. Maybe that's helpful. Okay, let's mark these as just what are they? So we're going to randomly assign letters A, B, B, C, C, and D, D. We'll have Z, Z, Y, Y, X, X, and W, W. Okay. Okay. Yeah, we have those are the same. DC, YZ. So where is this digit in column 3? Can't be any of these. Can't be C or D. Can't be Y or Z. Can't be this cell because it's the same. So this cell here must be one of those two cells there. Does that help us much? I'm not sure if it does. Where is this cell that's matching with the orange cell here to add up to that cell? Cannot be C or D, cannot be Y or Z, and it can't be this cell. Can't be any of these cells in that box. So this must be 1 through 5 here. Obviously, this can't be 1 or 2. So this cell must be at most 1, 2, 3, or 4, adding up to 5. Because this cell is missing in column 3. It cannot be here. It cannot be any of these because it sees them, or YZ, and it cannot be this one because it adds up to that digit. This digit is different than the orange one, and it sees, again, DCYZ, so that eliminates all of those. It's obviously not the orange one because we designate it not the orange one. It can't be here, it can't be here because it adds up to that, so it must be one of these two. So this is 1 through 5, and this has to be okay. So we've proven something then. This is 1 through 3 here. If this were 3, and that matches this 3, this would have to be 5, but then you'd have a 5 here. And this would be 3 and 6 adding up, so this would be 6 here. This would be 1, 2, 3, but that could never be a 5. So this cannot be 1, 2, and 3 here, guaranteed. Because if this is 1, 2, or 3 here, this is also 1, 2, or 3. That means both of these are 1, 2, or 3, which means that's 3. That's a 1, 2 pair adding up to 3, which eliminates all possibilities for that cell. So this cannot be 1, 2, or 3. It's 4, 5 here, which means these can't be 4 or 5. We have a guaranteed 4 or 5 here. If this were 3, that would make this 3, 6, because this could no longer be the 3. And then the problem is this being 3 and 6 is this would be 6, so that'd be 1, 2, 3. So this can never be 6 here. So this is 7 or 8. We have a guaranteed 1 here. Interesting. If this is 1, I guess this could be 5 here. So the only way, if this is 8, this becomes 1, 8, that's 9. And this can't be 7 anymore, because it must be greater than orange. So this could still be 7, 8, and we have a 7, 8, 9 triplet now in column 6, or column 9, which eliminates 7, 8, and 9 in the rest of the column. This can't be 7 because of one, either this is 7 or this is 7, right? If this is 8, that forces this to be 7. Otherwise, this is 7, which forces this to be 7, 8, or 9. Or 8 or 9, I guess it would say. But, yes. So if we tried to make this 6, 3 and 6 doesn't work. Because that forces this to be 3 in one of these spots, and we need... This is 1, 2, and 3. So this would be 1 or 2 or 3. And then that matches this cell here. So, this has to match this cell. So it's 4 or 5. This can no longer be 6, so it can't be 3 with 6 or 7. This must match this cell here. So it's 1 or 2. Interesting. Okay. If this is 2 and 7, that would mean this has to be 2 and this is 7. So this would be 4. This would be 4, 1, 3, and that does work. If it's 1 and 7, that does not work. Because if this is 1, 7, so 2, 7 works because that would force us to be 2. This would have to be 4, and 4 would be 1 and 3 added together, and that does work. If we tried to make this 1, 7, that would mean this would be 7, so it's 1, 2, and 4. This would be 1, and that would be 4, which would have to make that 1 and 3, which is not possible. So either this is 2, 7, or this is 1, 8, which forces this to be a 9 no matter what. And since this is 9 no matter what, this can no longer be 9. This becomes a 7, 8 pair. This 7, 8 pair then adds up to 50. It eliminates 7 and 8 in the rest of the row, so 9 has to be here. Where is the 9 in row 2? Can't be here because of the 9 in the box. Can't be here because it sees that from palindrome and normal Sudoku. Cannot be on the arrows. Can't be here because of the 9 in the column. So this must be a 9. So that matches that 9. This must be 1, 2, 3, 4, 5, adding up to 15, which adds up to the 7 plus 8. So that eliminates 1, 2, 3, 4, 5 in the rest of that box. So this is a 6, 9 pair here. So this is guaranteed. If this is 5, this becomes 5 here. It matches that. This is 5, 1, 2. So that's 8, which makes this 1. So if this is 5, this is 2 and 3. If this is 4, obviously it's 1 and 3. So this is 1, 2, or 3 here, with a guaranteed 3 being here. This cannot be 4, 5. This cannot be 4, 5. So there's a guaranteed 1. Okay, so 3 is eliminated here. Interesting. Therefore, we have a 1, 2, 3 triplet in row in box. Well, we have a 1, 2, 3 triplet in row 2. That eliminates 1, 2, and 3 in the rest of the row. So this is 4 through 8. That means this is at least 5. So it could be 5 through 9 here. Blue is one of these two. We don't know which. So 9 is here. 9 is here. 9 has to be one of these two digits. Where is the 9 then in the box 5? It has to be with a 7 or 8. Cannot be C or D. Cannot be Y or cannot be X or W. It can't be along the arrow. So this is 7, 8, and 9. And this is the other blue. Okay. The rest of box 2 is 4 through 8. So B is 4 through 8 also. This digit, again, must be one of these. So this digit matches this one. This one matches this one. So I guess we'll make that green. We'll make this dark. So that matches that. So this dark cannot be here or here, so it's one of those two. And then it becomes one of those 3. Dark, we know, is also one of those 3. Cannot be Y or Z. This green matches this one and is one of these two. It cannot match this one, so it must be that one. We don't know which one, though, it is. This is at 1 through 5 here. We don't know which one. Remaining digits in row 8 are 1 through 5. So that means this is 1 through 5. These are 1 through 5, and this is 1 through 5. 7 and 8 cannot be here. Where is orange? Again, orange is one of these two. This one could be Z. We're not completely sure. Okay. So dark could match here and here, which would force that to be there. That's possible. That means green has to be one of these three here. It matches one of these, obviously. It could be any of these six, though. We do know it's over here, though, so it has to be one of these three also. Hmm. Interesting. 9 in box 4 must be one of those two. Obviously, it's one of those two. So this is blue and orange. Oh, this is a blue-orange pair. Where is Y and Z then in box 5? It must be the same as W and X. So this has to be a YZ pair. We don't know which one's which, though. Oops. So this is a YZ pair. C and D cannot be the green, cannot be this one, can't be this. So it must match the B and this cell. So this is C or D, and this is C or D. And we know it's 4, 5, 6, 7, 8, but we don't know which one. So that means, what is this cell? Y and Z matches these. Actually, is that true? That's not true. That's not guaranteed, no. It could actually match one of these. We know the green has to be here. But that doesn't prove us anything else, right? Y could be also one of the low digits here. Huh. Right, so that's not correct. Okay, so then we go back to what we had previously. Um... Ah. That's not true. If this digit is a 6 and not 9, it sees all of these cells, so it cannot be here. So if this is 6 and not 9, that's 9. That would force us to be 9 there. This 6 would eliminate 6 here, and it sees those cells, so it couldn't be there. So it must be there, then, in that case. Ah. Right. We have a 1, 2, 3, 4, 5 quintuplet. in column 7. And the reason why is these two match. These two match, so they're 1 through 5. This must add up with 4, 5, 6, 7, 8 to add up to 5, 6, 7, 8, or 9. So this can never go higher than 6. This is 1 through 5, 1 through 5, 1 through 5. These are 1 through 5 because they must add up to 15 for 5 unique digits. That eliminates 1 through 5 in the rest of the column. So this cannot be 4 or 5. It's 6, 7, or 8. This is 6, 7, 8, and 9. This is 6, 7, 8, or 9. Cannot be 9. So this is 6, 7, or 8 here. That means this must be at least 7, 8, or 9. So it matches one of these. Guaranteed. We don't know which. This must be 1, 2, or 3. To add up with 6, 7, or 8 to add up to 7, 8, or 9. This is 4, 5, 6, 7, 8. Interesting. Can this ever be 6 is kind of the question. If this is 6... Okay, I don't think this can ever be 3 and 6. Well, okay, if this is 6, this is 9, that's 6. And then this is problematic, because these two digits must be exactly the same as these two, but they both see 6, and this is 9. So it's obviously a contradiction. This can never be 6, it's 7 or 8. So this matches one of these two there. This cannot be 3 then. This can't be 7 anymore. Can this ever be 8? So if we had this as 8, this is 7, that's 1. This would have to be 9. That would force this to be 6, which force that to be 9. That would force this to be 8. 7 would have to be one of these two. This could not be 7 or 8. Oh. Hold up. We do have more information. Anyways. This can't be 7 or 8 because of a 7-8 pair in the column. This can't be 7 or 8 because of a 7-8 pair in the column. This 7-8 means this can't be 7 or 8 because of the 7-8 pair in the column. This can't be 7 or 8 because of the 7-8 pair in the column. The rest of column 9 must be 1 through 6. Okay. This digit then is 1 through 6 also, because it matches that cell. Okay, so we have a 1, 2, 3, 4, 5, 6 sextuplet in box 3, which eliminates 1, 2, 3, 4, 5, 6 in the rest of the box. This cannot be 6, so one of these is guaranteed to be 7. because this can't be 7 anymore. This is the sum of 7 and 1 at least, which is 8. That eliminates 7 in the rest of the column. We have... No, we don't. Never mind. Okay. If this is 8, that means this must be 8 here. If this is 6, this becomes 9, which makes that 6. So this would be 9. It seems fine. Oh. If this is 2, 7, this would obviously be 7, and this would be 1, 2, 4. We've tried 1, 7 here. That doesn't work in this case, because this would be 4. So 1, 7, this would be 4, 1, 2. This would be 1. This would be 4. That would be 1 and 3, which would be a contradiction. So if this is 2, 7, this becomes 4, 1, 2. If this is 1, 8, that means this has to be 1. This is 8. And this must be 5 and 2, 3. So this is 5, 1, 2. So either way, this is guaranteed to be a 1, 2 pair, which means this cannot be 1 or 2. This has to be 1 or 2, 1 or 2 here. This would have to be guaranteed to be 1 or 2, so this can never be 2. We have a guaranteed 3 here. Where is the 3 in row 7? It must be one of these 3 cells. So this is 3, which means 3 cannot be here. It cannot match there. 3 has to be one of these 3. The rest of the digits in column 6 must be 3, 4, 5, 6, 7, 8. Okay. That means 3 has to be one of these 3 digits there. Either 3... Okay, so where is the 3 then in column 7? It must be either this cell or this cell. Obviously, it could be both of these. So I think we're making one of these pink also. So obviously pink is one of these. Pink has to be one of those 2. So pink is, we don't know. It's one of these 4. So this must be pink, green, and dark. We don't know which one's which though. This could match one of... No, cannot match either of these. So this must match a C or D. but we don't know which one. Because yeah, this cell sees both of all of these. It cannot be the green or the pink. It cannot be the orange or the blue. Because this is blue. That's orange. So this must be W or X. Because it sees C and D. It cannot be the 1-2 pair here, no matter what. No, it could be. Okay, so this is specific to column 6. Because these two cells must be these two cells here. They add up to the orange, so they can't be the orange. These two plus these must add up to that, to add up to orange, because we already have those adding up. So it can't be here, obviously. These three add up to the orange, so this cannot be the same. So they must be those two specifically. So that's that's just specifically column 6 then. So this cannot be dark. This can't be dark either because this is dark. So dark could be... Where is dark in column 7? Can't be either of these. Can't be here. Can't be here. Could be here or here. So the dark has to be one of those two. Does that tell us anything? Not particularly. If this is dark, then this is dark, which means this can't be dark. If this is dark, this can't be dark. So this can never be dark, period, here. Which means this cannot be 4 or 5. It's 1 or 2 here. Huh. Does that tell us anything? I don't know. Oh. This cell sees both this cell and this cell. So that means it cannot be either of these cells here. This cell sees this cell and this cell, so it cannot be either of those cells. That eliminates 1 and 2 along these two cells, right? This cell is one of the 1 or 2s. It sees both of these cells. This matches that one, so this can't be one. This eliminates this cell along this row. This cell sees this cell and that cell, which matches both of these cells. So both of the 1 or 2s see both of these cells. So it cannot be 1 or 2. This becomes a 4-5 pair, which eliminates 4 and 5 in the rest of the box, or row, and box. So one of these is dark. This is guaranteed. That means one of these two is dark. One of these two is dark. That guarantees that this can never be dark, right? One of these two is dark. One of these two is dark. That means we have 2 darks in column 7 and 8. So this cannot be dark here, which forces this to be dark. We also have a 4-5 pair in box 6, which eliminates 4 and 5 in the rest of the box. So this can't be 4 or 5. This can't be 4 or 5. It must be 6, which means this is 6, so that matches 6. That also eliminates 6 in the rest of the column and row and box. This can't be 4 or 5 because of the 4 or 5 pair in the box. This 6 eliminates 6 in the rest of the box, so this is 8. This 6 eliminates 6 here, so it's 9 and 6. 9 eliminates 9 here, so this must be 8. This 8 eliminates 8 here, so it's 7, which makes this 1, which makes this 9. That eliminates 1 in the rest of the column, so this can't be 1 anymore. That eliminates 1 in the rest of the box. This is 2 or 3, which matches this 2 or 3. Z cannot be 1, 2, or 3 then, because we have a 1, 2, 3 triplet in that box. So Z must be 7, because it can't be 4, 5 because of the 4, 5 pair in this box. Can't be 6, can't be 8 or 9, can't be 1, 2, or 3 because of the 1, 2, 3 pair in this box. So Z must be 7, which makes this not orange. This must be 1, 2, or 3. The oranges must be 8. So this is 8, this is 8, this is 8. This must be 1 and 8. That leaves the green as 1. This must be 1, 2, and 5. So the green is there. That means this is 1, this is 2. This must be 1, 2, and 5, adding up to 8. This must be 3 and 4, adding up to 7. This 5 eliminates 5 in the rest of the column. This can't be 8 because of the 8 in the column. 7, this can't be 8 here. This is orange, so this cannot be orange here, which means this is blue. This can't be blue. This is orange. This is 8. This is 9. That leaves this digit as a 9 because we have limitations. This can't be 9, this can't be 9, and this can't be 9 anymore. So that leaves that as a 9. We have a 1, 8 pair here. Remaining digits in box 5 are 3, 4, 6, 7. This 8 eliminates 8 in the rest of the column, and it eliminates, this can't be 8 anymore. This can't be 8 anymore. This can't be 7, so one of these two here is a 7, which means this can't be 7 there. And this can't be 7, this can't be 5 either. So that means this is not 5 or 7, it's 4 or 6. Where is the 4 in row 7? Cannot be here because of the 4, 5 pair in the box. This adds up to 8 with 1, 2, and 5. So this must be a 4 here. So this is 4, which makes that 4. So this can no longer be 4. We have a 3, 6, 7 triplet in row 7 because that's all that's left. That leaves this as a 1. So this is pink, which means this 1 eliminates 1 here, so that's 2, which makes this 1. This is obviously still the pink. And this is not pink. So pink cannot be here. This must then be 3. This is 5. That eliminates 5 in the rest of the row, in the box and row. And this must be 5 here. This is pink and 2. These can't be 5 anymore. These can't be 4 anymore because of the 4 in the row. That means these can't be 4. These can't be 4. One of these two is a 4. We don't know which. This becomes a 3, 4, 6 possibility. This can't be 6 because of 6 in the row. So this can't be 6. This can't be 6 either. This is a 2, 3 pair, which eliminates 2 and 3 in the rest of the box. So this cannot be 2 or 3. It's 4. This can no longer be green. This can't be green and can't be 1. We have a 2, 3 pair in box 6, which eliminates 2 and 3 in the rest of the box. So this can't be 2 or 3. That's 1, which eliminates 1 in the rest of the column. So this cannot be the green, which means this is the green here and is 1. 3 eliminates 3 in the rest of the column, so this can't be 3. This can't be 3. The remaining digits in row 9 are 5 and 6. So this is all done. This is the same as this. Okay, so we can remove colorings that we have. Oops, colorings. And we should start coloring 2 3s and 4 5s as pairs. This digit, okay, so this, we're going to make it orange, and this will mark as blue. So this is blue, which makes this orange. Okay. Blue has to be one of these. This is blue, orange as a pair. So this 3 eliminates 3 here. So this matches this. This is 6 or 7. This cannot be 6. We have remaining digit. Okay, this cannot be 8 because of the 8 in the row. Therefore, we have a 2 3 pair left in row 1. We have a 6 7 pair in box 2, which eliminates 6 7 in the rest of the box. So this can't be 6 or 7. It's 5, which forces this to be 8. This 5 eliminates 5 here, so it's 4 and 5. 4 eliminates 4 here, so it's 3, which makes this 7, this 6, and this 4. That matches that cell, so this is 4, that's 3. This 3 eliminates 3 here, so that's 2, which makes this 2, makes that 3. This 3 eliminates 3 here, so that's 2 and 3. This 2 eliminates 2 here, so it's 5 and 2. These can no longer be 2 here, so it's a 1 3 pair. Remaining digit in row 4 is a 6. Again, this 6 matches this cell, so this is 6, which makes this 7, which makes that 6. This can't be 6 or 7 because of a 6 7 pair in the row. This becomes a 7 or a 6 as a possibility. This 4 eliminates 4 here, so it's just 5, which makes this 4. This 6 eliminates 6 here, so it's 3, which makes that 7. This 4 eliminates 4 here, so it's 3 and 4. Remaining digit in row 6 is a 5. Remaining digits in row 5 are 2 and 7. 5 eliminates 5 here, so it's 6 and 5. 6 eliminates 6 here, so it's 7 6. 7 eliminates 7 here, so it's 2 and 7. 2 eliminates 2 here, so it's 3 and 2. 3, we have 3 in the corner. We celebrate because we know we're close to solving it. Eliminates 3 here, so it's 1 and 3. 1 eliminates 1 here, so it's 8 and 1. 8 eliminates 8 here, so it's 4 and 8. Congrats, I hope you enjoyed. It was hairy. It was definitely a lot of interesting palindrome things, right? So there's a lot of interesting little tidbits, which having these essentially. So it's basically along row 4 in column 3, and row 7 in column 6 were very interesting. That was interesting interactions. Also, I guess with these cells, well, that was part of all column 3 and row 4. And that was sort of matching this. And I guess this box 9 was interesting too. I guess, yeah, there was also this part where they were forced to have a 1-2 pair here, and that interacted with this palindrome line very interestingly. That forced us to be a 4-5 pair. Huh. Yeah, it was interesting throughout. There's a lot of intriguing little things which you had to sort of deduce. Anyways, I hope you enjoyed that solve, and I'll see you next time on Frank Puzzles. Take care.